Right now, Earth is moving through a massive river of cosmic dust, an invisible stream so large it surrounds our planet without anyone noticing. To the naked eye, space looks empty, but it isn't. Every January, Earth enters one of the densest regions of interplanetary debris in the entire solar system. Millions of microscopic particles begin drifting into our atmosphere silently, endlessly, without any visible sign. This phenomenon is known as the January dust stream, a cloud composed of ancient comet fragments, meteor remnants, and grains of rock older than our sun. Most of these particles are smaller than a grain of sand, but together, they form a structure tens of millions of kilometers wide. And for several weeks, Earth is inside it. To understand where this dust comes from, we look back to the early solar system. When comets passed through the inner planets and left behind long, delicate trails of debris orbiting the sun, over thousands of years, these trails spread, thinned, and became part of a giant, slow-moving river of particles. This river is made of ancient comet debris, micrometeorites, and fragments from the breakdown of larger bodies, and Earth crosses this region every year, precisely in early January. The reason has to do with the shape of Earth's orbit. At this point in the year, our planet reaches perihelion, the moment it is closest to the Sun. During this time, Earth passes through a section of the solar system, where the density of dust is slightly higher. This is the same region that produces the quadrantids, one of the strongest meteor showers of the year. Most of the dust particles never reach the ground. They enter the upper atmosphere, burn faintly, and vanish long before they become visible meteors. But some survive. These survivors fall to Earth as micrometeorites, tiny pieces of cosmic material that land everywhere, on oceans, deserts, forests, cities, and even rooftops. Every day, Earth collects tens of tons of this material. Over a year, that becomes thousands of tons, enough to form a thin layer across the entire planet, a layer we never notice, but one that is always there. It's a quiet reminder that space is not distant. It arrives constantly, grain by grain. The effects of this dust are subtle, but real. In the upper atmosphere, particles scatter sunlight, slightly altering how blue the sky appears. They influence the formation of high-altitude clouds. They modify how the ionosphere responds to solar radiation. And collectively, they add mass to Earth, even if only by a tiny amount. On the surface, micrometeorites accumulate in remote regions like Antarctica, where scientists have collected them by the thousands. These particles are perfect, rounded spheres created by atmospheric entry, each one a fragment of something that once orbited the Sun long before humans existed. But the most surprising effects happen on a larger scale. Cosmic dust contributes to a process called atmospheric nucleation, where small particles act as seeds for ice crystals and cloud droplets. In the long term, this influences cloud formation patterns across the planet, not dramatically, but measurably. And so, during January, when Earth passes through the densest portion of this dust stream, these subtle interactions become slightly stronger. More particles burn in the atmosphere. More micrometeorites fall to the surface. More dust enters the global system. Quiet changes, invisible to us but constant. We often imagine space as a perfect vacuum. But the truth is far quieter and far stranger. Earth does not simply move around the Sun. It moves through the remains of ancient worlds. Dust from comets that disintegrated hundreds of thousands of years ago. Fragments of asteroids shattered in collisions we never witnessed. All of it drifting toward us and eventually becoming part of us. Part of the air, part of the ground, part of the planet itself. Grain by grain, Earth absorbs the history of the solar system, and every January, the process becomes easier to see. The question is not whether this dust affects our world. It always has, and it always will. The real question is how much of Earth's story has been shaped by material that did not come from Earth at all, and how much of our planet's future will depend on what continues to fall from the sky, silently, every single day.